Okay, welcome back. This is Chapter 10. Chapter 10 is all about communications and networks. Make sense? Cool. Let's start with the learning objectives. So turn to page 416. It says, discuss the purpose of the components required for successful communication. Differentiate among LAN, MAN, WAN, and PAN. Differentiate between client, server, and peer-to-peer. Differentiate among the star network, bus, and ring topologies. Describe the various network communication standards and protocols. Explain the purpose of communication software. Describe various types of communication lines, of physical lines. Describe commonly used communication devices. Discuss different ways to set up and configure a home network. Differentiate among physical transmission media and differentiate among wireless transmission media. Okay, so they start off with a fairly simple little definition of what that type of communication is. And so they talk about digital communication describes a process in which two or more computers or devices transfer data, instructions, or information. So it starts with a sending device, then you have some sort of communication channel, and you have a receiving device. Now, admittedly, most of the devices can both send and receive, but the point is, it takes three pieces for the thing to work. A sending device, some sort of a transmission channel, and then something at the other end to receive it. Kind of makes sense. Okay. On page 418, they talk about the definition of a network. And again, their definition is, it's not bad. A collection of computers and devices connected together via communication devices and transmission media. Okay. Well, that's half bad. Bottom line is you got a bunch of computers and you got a bunch of cabling and all the network architecture, plus, in addition to the hardware pieces, you also have a set of protocols that everyone has agreed to use in order to make everything work. They talk about the advantages of network. These are incredibly obvious, so don't have to bother writing them down. Facilitate communication. You can do email and stuff. Sharing hardware. Now this is a big one. When we first started getting networks a million years ago, the key was I could share a printer. So if I had a super duper color printer and I had it on my desk, I could print nice colored photos and stuff, but nobody else could. Well, when we got network, then I could share out that printer and everyone could print nice color items. So, the sharing of hardware. So typically file and print services were the first use in modern kind of business scenario. Sharing data and information. Clearly, if I have a central database with all of my data in it, then I have to use a network in order to make it work. There's no other way unless you get out of your chair and everyone goes stand in line to sit down at the database server, right? That'd be kind of dumb. Sharing software. This is not quite as prevalent as you might think unless you're considered like a web scenario where I don't actually have software installed on my machine. I have it installed on the web server, and so everyone just uses the software there, and I don't have to go around to every machine and do updates and things of that nature. And then transferring funds, which is kind of an odd thing to throw into this little group, but hey, what the heck. Okay, towards the bottom of page 419, now they're getting into some of these definitions that we talked about at the very beginning. What is a local area network? So a LAN is a network that connects computers and devices in a limited geographic area. Now there's a little bit more to this, but a typical Ethernet cable, don't worry about what that means in just a minute, but a typical network cable has a range of about 100 meters. And yeah, there's a ways you can extend the range, but central idea is if you're in an office and you've got a big building, you're basically going to have a local area net that covers one little area, and then a local area net comes another area, and some sort of a connection between the two, because you basically have a 100-meter range, which is why, for example, the network closets are never at the edge of the building, right? Because it kind of goes out, it's a radius of 100 meters, so you want to put it smack dab in the middle of a building, wouldn't you? Okay, cool. The next one on page 420, they talk about a wireless LAN. Now, there's no real difference from a LAN perspective. We haven't talked about the technology yet, but just from the definition of what a local area network is, it's the same. So essentially, you're talking about the same kind of a scenario. You know, a business environment where I own all the machines, I own all of the networking components, and I have about a 100-meter range. Well, it's the same thing in the wireless world. It's just instead of using wires, you're using the air. But the central components are essentially the same. So on page 421, they talk about a metropolitan area network. Now this is sort of like, let's say I've got two buildings, and so I've got a building over here that has a LAN, then I have a building over here that has a LAN, but I need some way to connect the two together. So I typically am not going to go out there and string wires across the road. Okay, that's not normally what people do, mainly because they don't have permission to string wires across the road. You know, climb up on somebody's telephone pole and hook a wire up and spin it across to the other side and hook it up. I mean, that's not normally the way it works. So typically when you come to a metropolitan area network, there's a third party involved. So I own all of the hardware, software, all the networking components in this building. I own all the networking components on this, but I'm contracting out for that loop between the two. Okay, so a metropolitan area network typically is one of those connections where I go to a third party and say, I need a high-speed internet connection that connects these two buildings. It doesn't really matter how far apart they could be, you know, 200 feet apart, or they could be, you know, 20 or 30 miles apart. Anyway, bottom line is, I don't own that piece in between. Okay, so a wide area network is one of those scenarios where, okay, I'm gonna need to hook up my city, you know, my building in Dallas to the building in Houston. Okay, now you know darn well I am not going to be stringing fiber optic cable between Dallas and Houston, right? I'm a shoe store, right? That's what I do for a living. I sell shoes. So I'm not going to be running fiber optic cable. That's way too expensive. So once again, it's going to be, I'm going to contract out for that service with a third party to provide me a connection on, hopefully, some sort of cable that already exists. Okay, so the difference between a MAN and a WAN really is a matter of scale. If I'm talking about short distances, I can get incredibly fast speed. You know, it's not at all difficult, for example, for me to get, you know, 10 megabit up, 10 megabit down inside my own town. You know, from one edge of town to one edge of town, that'd be pretty easy to do and fairly reasonable cost. But if I wanted 10 up and 10 down between Dallas and Houston, that would be rather expensive, and I might have to crank down my expectations a little bit to get a reasonable price. I might have to go lower on my speed. So it's a matter of scale and the fact that the longer the distance, the more it's going to cost me, and perhaps I need to compromise. I mean, if you've got plenty of money, no big deal, but you might compromise on speed. Okay, so the next one is called a personal area network, and that's those devices that typically talking about a single office. I have a wireless mouse and a wireless keyboard, and I have a Bluetooth connection on my phone, and so I'm doing all these things wirelessly, right? And yet the range is about 30 feet. Now, yes, you can get ultra range extenders and do all sorts of other things, but we're talking about a single room in a house, or a single set of cubes in a cube farm in a building. We're not talking about monsters. It quite literally is a personal area network. All right, one more time. LAN, wireless LAN, same thing in this talk. A metropolitan, which is, you know, I got to go in between buildings. A wide area, which means between cities, and then personal, which is, you know, all my stuff in range of about 30 feet. Okay, so the real difference between all those is who owns the piece in between and what is the scope. Okay, let's continue. On page 442, they talk about the network architecture. And there's two basic types of way of thinking about how networks work. One is called the client-server model, which is I have like a centralized database. And I want the database to be centralized because I don't want changes over here to not be reflected over here. So I really don't have much of a choice but to have one copy of the database, and everyone else connects to it. So That would be an example of a client-server kind of a thing, where all the processing happens at the database. And these people just attach to it from their PCs, but there's no real processing of the data down in the PC layer. Everything happens up at the top. And there are scenarios where this is absolutely desirable, that kind of thing. A lot of people look at it and go, client-server, that's ancient. No, it's not. It's been around for quite some time, and it's going to be around for quite some time. The next one is called peer-to-peer, where there's no real difference. Everyone has a PC. There really isn't a server per se. I mean, a dedicated box being a server. So my machine is acting as a print server, and my neighbor's machine is acting as a file server. They're all PCs. They're all just hooked together, and you can just kind of elect, oh, I think I'm going to be the file server today. And you can flip a switch, so to speak, and share out files. Or wait, I'm going to turn on print services, and so you can share out your printer. So everyone's kind of equal in that scenario, where there is no one central controlling thing, no subordinate kind of a scenario where you have something at the top and then you have other things coming off of it. So that's the difference between the two. So in addition to that configuration option, we also have the thing called a network topology. And this is kind of weird because they show these diagrams, and the diagrams are kind of misleading. So let me just go through them for just a minute. Okay, so a star technology, which means I have some sort of a central device, a doodad, and everything comes out of it. Remember how I talked about how if you had like an office building and the lengths of these cables are about 100 meters? So you'd want to put this central device like in a closet in the middle of the building, and then you'd have 100-meter cables coming out of it, right? Okay, so that's what a star network looks like. One of the older type networks, which I don't see anymore at all, is called a bus type network, where they have a single cable running down like the spine of the building, so to speak, and you have these small taps that come off of the cable, just like you'd have to do like with a water pipe, right? You'd have a water main going down the street, and you'd have a line coming off to a house, and you'd have another line coming out to the house. So everyone is sharing that water main. Now, as you can probably imagine, if the water main breaks, well then everyone is down. Now in the star technology, if this cable right here breaks, well no one else even notices, okay? So this is kind of an older technology back in the days when we had coaxial cable. You don't see this hardly at all. The next one is a little complex. There is this thing called a ring technology, where the cables are kind of hooked up into a circle, and the idea is that I put a message out on the LAN, and I have to wait my turn, and when my turn comes, it gets to send the signal and goes around in a circle. Now, the problem with this diagram is almost all of the ring topologies are done from a logical perspective. It's called a logical ring, not a physical ring. Trust me, the cables do not get connected as they show in this diagram. That is not how they look. They look just like this. In fact, if you were to walk into the wiring closet and you could not tell the difference from a physical look, the difference between a star network and a ring network, because physically they're going to look the same, but logically one is going to be sending signals to and from a central device, and others is going to be passing messages around in a circle. So consider this diagram a logical network diagram, not a cabling plan. Okay, got it. Good. Okay, on page 425, they talk about Ethernet. Now, Ethernet's been around a while. It's one of the oldest ones. It is standard. It is the most popular standard for doing local area networks. It's also the most popular standard for transmitting data, through the internet. So it just makes sense if I'm going to be using Ethernet kind of technologies inside my building. It'd be easy to contract with a third party, to go across. If I'm all using Ethernet, right? Okay, this is a good place to stop for the 15-minute mark. We'll pick this thing up again in just a few.